Hello, welcome to today's lesson looking at the periodic table. In the previous lesson we've looked at elements, compounds and mixtures. Today we're going to be looking at the periodic table. By the end of this session you should be able to state where metals and non-metals are found on the periodic table. You should be able to explain why certain elements are in the same groups of the periodic table, and you should be able to use the periodic table to predict the properties of an element. Now, as you would do for any other lesson, could you please write the title in your exercise book, put today's date, and we can make a start. So something that I mentioned last lesson, and I'm going to put it in red because it's an important point. All elements in known existence are shown on the periodic table. Okay, so all elements in known existence are shown on the periodic table. Now, we can use the periodic table to make predictions about the properties of an element. So we can say that, in fact, I'll go to this yellowy colour. We can say that using the periodic table, we can make predictions about an element's properties. Okay. Now, properties of an element is our first keyword, or properties of anything in science. It's a keyword, so I'm going to put it in green. Properties The properties of something in science are the characteristics that can be observed. So the characteristics of a substance that can be observed. Now, for example, we know that iron is a solid. So being solid is a property. We know that iron rusts. We can see that iron is rusting with our eyes, so that is a property of iron. It has the propensity to rust, or sometimes it rusts. We know that iron can be very, very heavy or dense, which we'll talk about later. So by being heavy, that means we can feel it, we can pick it up, we can observe it. That is its properties. Another property might be, for example, if you put magnesium in hydrochloric acid, you can feel heat coming off it. You can see bubbles. You can hear bubbles. These are all examples of properties. So if we pull up a copy of the periodic table, it looks like this. Okay? This is one that I prepared earlier. And you would have learned in your other topics looking at metals and non-metals that metals on the periodic table are found on the left-hand side, whilst non-metals are found on the right-hand side. And an easy way to divide this up is by starting with aluminium. You can put a staircase all the way down the periodic table. On this side, we'll have the metals, and on this side we have the non-metals. Okay? So I'm going to put in red over here because it's important that all elements on the left-hand side of the periodic table are metals, whilst those on the right are non-metals. Whilst those on the right are non-metals. Okay? So everything on this side of the red line are metals, everything on this side of the red line are non-metals. Now, interestingly enough, it's not really applicable to this lesson, but we'll talk about it anyway. These elements found near this red line are known as metalloids. Okay? You've learnt in other topics that you've had in science that metals have certain properties and non-metals have other properties. So, for example, metals are shiny. They are usually a metal at room temperature, so they have a high melting and boiling point. They are very, very dense. They conduct electricity. They are sonorous. They are ductile. They are malleable. Whereas non-metals are brittle. They are not very dense. They do not conduct electricity or heat very well. However, metalloids I can't remember if it's 1L or 2, metalloids are elements with the properties of both metals and non-metals. Of both metals and non-metals. Okay? So some examples of different metalloids would include boron, would include silicon, astatine. All these would be metalloids. They would share properties of both metals and non-metals. I am going to refresh the screen. So the beauty of doing this on video is that you can pause the video whenever you want. So pause the screen now if you haven't got all the notes down and press play when you're ready to continue. So we've spoken about the basics of the periodic table. We've said that metals are found on the left and non-metals are found on the right. We don't want that open. What we now need to think about is this idea of groups and periods. Okay? Now, groups of the periodic table are the vertical columns. So we can put groups as our next keyword. Groups. And we can say that these are the vertical columns. I think they know to spell columns. The vertical columns of the periodic table. Okay? So just to be clear, the groups run from top to bottom. Okay? So groups run from top to bottom. And you'll notice on this periodic table, they're numbered. So we've got group 1 here with a number 1 at the top. We've got group 2 here with a 2 at the top. Group 3, 4, 5, 6, 7, and 0. Sometimes you may see group 0 referred to as group 8. Okay? It depends on the periodic table being used. These elements in the middle that do not have group numbers are known as the transition metals. They do not have group numbers, and I'll explain why in a second. So these are known as the transition metals. Now these have got some common metals inside there. We've got, for example, nickel, copper, zinc, any others that you may know about. We've got gold and silver, mercury. We've got any others that you may know, tin. These are all metals found in the transition metals. Now, the groups that run downwards, run in vertical columns on the periodic table, all of the elements in a single group will have similar properties. So, for example, all of the elements in group 1 are highly reactive. If we put these metals, because they're on the left-hand side of the periodic table, if we put them in water, they burn. On the other hand, the elements in group 8, or 0, depending how you want to call it, these elements are very unreactive. They don't react with anything. They are very, very stable. So we can add underneath our definition for groups, and I'm going to put it in regs, it's important. We can say that the elements in a group have similar properties. Okay? So the elements in a group have similar properties. Now, as you move down a group, there will be a pattern in properties. Okay? So, for example, as you move down group 1, its melting and boiling point decreases. Okay? As you move down group 1, you get more reactivity. As you move up group 7, the reactivity increases. So with this one, it increases as you're going down. With this one, it increases as you're going up. We'll talk more about those in future lessons. We're going to do lessons on each of these groups. So we can add underneath here by saying that going down a group, there is a pattern in the properties. There is a pattern in properties. Don't have two S's, do we? Properties such as melting point, and boiling point. Okay? So as you go down a group, there is a pattern in certain properties. For example, you could have the density changes. Density is how much mass something has for its volume. So we'll put that as a keyword over here, density. And we can define density as how much mass something has compared to its volume, or for its volume, we'll put for its volume. Okay? So groups, the elements in a group have similar properties, and as you move down a group, these properties will show a particular pattern. So for example, reactivity increases, reactivity decreases, melting and boiling point decreases, melting and boiling point increases. Okay? The transition metals do not have these groups because they do not have these properties that are so similar that we can put them into groups. Therefore, there's this massive gap. Okay? All you need to know is that these are called the transition metals in the middle. This is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8 or group 0. Hydrogen is on its own. Hydrogen is not in any group, it's not in any period that we're going to speak about now. So our next key term, and probably our final one, is the word period or periods. Okay? Now, periods are the horizontal rows of the periodic table. So we can say the horizontal rows of the periodic table. Okay, the horizontal rows of the periodic table. Now, going across a period, there will be a pattern in the properties of the elements. Okay, so we can say moving across a period, comma, there are repeating patterns in the properties of elements. Okay, and we'll explain what that means in a second. So if we were to think about the periods of a periodic table, or of the periodic table, if I can change my colour, have I got a highlighter here anywhere? And let's make it a bit thinner. Oh, we don't want to do that, do we? We go here, let me see what that looks like. It's a bit funny, isn't it? There we go, if I click that, and we want, oh no, that's colours. Oh well, don't matter, you know the idea I'm trying to get. Period 1 would be these ones, okay? Period 2 would be these elements. Period 3 would be these elements. So these are the horizontal rows that run from left to right. Period 4 would be these elements. And so on and so forth. Okay? So we can write on here that this would be, I need my pen, this would be period 1, these would be period 2, this one would be period 3, this one would be period 4, and so on and so forth. So the periods run from left to right. So we can add underneath our definition by saying that periods run from left to right. So they are the horizontal rows. These are the groups that go from top to bottom. These are the periods that go from left to right. Now, as you move across a period, things like melting point shows a repeating pattern. So if we focus on period 2, lithium has a fairly low melting point. Beryllium is a little bit higher. Boron is a little bit higher. Carbon is by far the highest. Then after carbon, melting point drops, and all nitrogen, oxygen, fluorine, and neon all have the lowest. Again, we're going to have on period 3, sodium has a low melting point, magnesium has a little higher melting point, aluminium has a little higher, silicon has the highest, and then phosphorus, sulfur, chlorine, and argon have by far the lowest melting points. We get this, if we were to draw a graph of it, if I would just sketch it, so we've got melting point here, and we've got, oh no, sorry, not melting point there. What am I doing? It's not melting point there, sorry. We've got element along the bottom, and we've got melting point up the side. If we were to do this for period 2, we've got lithium, we've got beryllium, we've got boron, we've got carbon, nitrogen, oxygen, fluorine, and neon. If we were to draw a graph of these results, what you would get is lithium, then you'd get beryllium, then you'd get boron, then you'd get carbon, and then after carbon, they would actually go into the minus figures, so they would be much lower. And you would get this repeating pattern every time you go across from one period to another. So to summarize, groups are the columns that go from the top to the bottom. They have similar properties, so the elements in a group have similar properties, and as you move down a group, there will be a pattern in properties. So for example, melting point may increase or decrease, density may increase or decrease, or any other property that can be measured. Periods run from left to right, but always bear in mind that period 1 is hydrogen and helium, okay? Periods run from left to right and they show repeating patterns of properties. So you should now be able to state where metals and non-metals are found on the periodic table. You should be able to explain why certain elements are in the same group of the periodic table, and you should be able to use the periodic table to predict the properties of an element. If you are asked to predict the properties of an element, in fact what we'll do is we'll clear the screen and we will play a bit of a game that you can play along at home on your own. I know it's not the funniest thing in the world, but hey ho. So I'm going to put in again the dividing line for metals and non-metals, and I'm going to pick an element that I want you to give the general properties for, okay? So the element I am going to pick is sodium. Pause the video now, give me the properties of sodium, and we'll talk through it. Okay, so you should have paused the video. You should have had a go at thinking about the properties of sodium. So the way I would tackle this is I would think, well, sodium is a metal because it's on the left-hand side of the periodic table. Sodium, therefore, is probably shiny. it probably conducts electricity, it probably conducts heat, it has a high melting and boiling point. These are all ideas I would get because I'm thinking that they are a metal. One thing that we haven't spoken about, I did mention it briefly earlier, but we're going to talk about it more next lesson, is that sodium reacts violently with water. Sodium is highly reactive, okay? It is a solid metal, but it reacts so easily that you'd get a bit of a fizzing when you add it into water. Let's try another. So this time we're going to do boron. See if you can predict the properties of boron. Pause the video first, then have a go. So you should have had a go at predicting the properties of boron, exactly like we did before. Boron is a non-metal, therefore you could say that it is brittle. You could say that it has a low melting and boiling point. You could predict that it is not very dense. It's not sonorous. It's not ductile. It's not malleable. This is an easy way to predict what elements are like on the periodic table. Simply divide your metals from your non-metals and make a prediction. As the lessons go on and we look at Group 1, Group 2, Group 7 and Group 0, you'll have a better idea of how to predict these properties, okay? So you should now be able to do these learning objectives. Thank you for listening today. If you have any questions, as always, do not hesitate to contact me and I will get back to you as soon as I can. Thank you very much.